Hello everyone. Take good reads give you a good thing to read to listen. Today I will talk about behind the Facebook, how to design a graph database. This is from a paper published by the Facebook maybe in the 2013. The title for the paper is TAO, Facebook's distributed data store for the social graph. First, let's see the common data models. The most heavily used the data model is relational databases. For this kind of database, that model is to support many-to-many relationships. We can see that for each table, it's composed by the rows, and between the tables, it can use foreign keys to link those tables together. For the relational databases, it's called schema on write. It means that before you write data into the database, you need to define the schema beforehand. Another data model is document databases. For such a database, each document has its elements and it can spread as a tree. This database is good at one-to-many relationships. It means one document and many elements can relate to it. For such a database, it's used the schema on read. It means that when you write to the data, you don't need to define the schema ahead. And when you read it, you must understand what's the data stored in the documents. But Facebook, when they want to use the data storage, they have their own challenges. We know that Facebook needed to store a social graph. Facebook have billion active users, and the data includes relationships, share their interests, upload texts, images, videos, and curate semantic information. These specific requirements gives the Facebook different challenges. We can see at the right side of the picture, there's a social graph. It's just to represent Alice was at the Garden Gate Bridge with Bob. With this information, Cassie commented, "Wish we were there." And then David likes this. If we want to represent these kind of relationships, we need to have the graph underlying. We can see that some of the nodes and also relationship between them. For example, the Alice is a node, is the type of the user, and another tab is check-in, and that check-in is authored by the Alice, and also Alice is authored check-in. We can see that only this small piece of the information of the social graph is really complex to represent them. To solve such a social graph problem, the original solution was MySQL plus Memcache. This is the very common open source solutions. We can use the MySQL as a storage and also Memcache as a cache to accelerate read speed. This is a kind of cache aside architecture. But this solution has its problem. The first problem is that inefficient add lists. For the social graph, it can be represented as a graph, so it's composed by the nodes, edges, and for the add list is the relationship between the nodes. And for such a list, a key value cache is not a good semantic fit for list of the edges. Another drawback for cache set architecture is the distributed control logic. The control logic is run on clients, and the clients don't communicate with each other. There's no central control for such a logic. The third big issue is expensive read after write consistency. So Facebook uses a synchronous master-slave replication for the MySQL. But for such a solution, it poses latency issues for caches in a replica. When the clients write the data first and then read that same data. It may be read the different replica, and the asynchronous updates may be not ready there, so they just read the old data from the servers. So Facebook invented TAO. It's a read-optimized graph data store. Let's see the TAO architecture. The dataset managed by TAO is partitioned into hundreds of thousands of shards. All objects and associations in the same shard are stored persistently in the same MySQL database and are cached on the same set of servers in each caching cluster. Individual objects and associations can optionally be assigned to specific shards at creation time. Controlling the degree of data collocation proved to be an important optimization technique for reducing communication overhead and avoid hotspots. There are two tiers of caching clusters in each geographical region. Clients talk to the first tier, called followers. If a cache miss occurs on the follower attempts to fill its cache from the second tier, called a leader. Leaders talk directly to a MySQL cluster in that region. All TAO writes go through followers to leaders. Caches are updated as the reply to a successful write propagates back down the chain of the clusters. Given this two-level caching hierarchy, care must be taken to keep TAO caches consistent. Each shard is hosted by one leader, and all writes to the shard go through that leader, so it's naturally consistent. Followers must be explicitly notified of updates made via other follower tiers. TAO provides eventual consistency by asynchronously sending cache maintenance messages from the leader to the followers. An object update in the leader includes invalidation messages to each corresponding follower. In normal operation, TAO provides read-after-write consistency within a single tier, and the read-through design of cache simplifies maintaining read-after-write consistency. TAO synchronously updates the cache with local return values by having the master leader return a change site when the write is successful. This change site is propagated to the follower tier that originated the write query. Client in the follower tier can see the updated data. For the Facebook scale, they need to scale geographically. It provides a better latency for the clients to request the data and also prevent data center failing. To make the different data center data in sync, the consistency messages are delivered to the slave leader as the replication stream updates the slave database. And then slave leader sends writes to the master leader C and read misses to the replica DB. The choice of master and slave is made separately for each shard. TAO's master-slave design ensures that all reads can be satisfied within a single region, at the expense of potentially returning stale data to clients. As long as a user consistently queries the same follower tier, the user will typically have a consistent view of TAO state. This is all the information about TAO. This is Chenny. Thanks for watching. See you next time.